Okay, Isabel, we are going to do a couple problems from your workbook. This was on the last page that we had looked at. I believe it was page 204. Don't have my notes with me. I know it's in the 200s. But this is number 29, the first one we're going to look at. And the directions say we want to solve each system of equations algebraically. So I'm going to go through, I think we went through substitution method. I'm going to do that again after this one, but I'm going to go through a problem with what we have two quadratic equations, two quadratic functions. They'd be parabolas on a graph. Um, Going through it with the elimination method. So finding our solutions, if any, by the elimination method. So we have two equations. They are y equals x squared plus 3x minus 5. The other one is 2y equals x squared plus 9x minus 6. And with the elimination method, if you recall, we're trying to um, either subtract or add one of the equations to the other, and doing it in a way where we're able to um, eliminate, hence elimination method, eliminate one of the variables. Because the problem right now is we have two variables on each one, right? We have these y's and we have these x's or x squares. So x and y in general. And until we can isolate one of those, we're not going to be able to really solve or find the solutions between these two. So I would say because y is only occurring here once on each one of these, and essentially it's x is occurring twice in both the x to the 1 and x squared. Let's try to eliminate the y's. Let's try to eliminate the y's. Well, how do we do that? Well, if I were just to subtract right here or add, I'd get either a negative y on this left side, that'd be 1y minus 2y, right? Or I'd get, if I added, I'd get a 3y, right? So I can't just, there's a 3y there. So I'm not getting it to 0y. Don't have my stylus here, I apologize. I'm using my finger and this little mouse, cordless mouse. So yeah, that's not going to work. We're going to have to manipulate one of the two equations in order to get it at a place where I can either immediately subtract or add it and then get rid of the y variable. Well, we could do one of two things. We could multiply the top by 2. So we call this equation 1 here, and we can call this equation 2. Well, I can multiply the top by 2 and get a 2y here, and then I'd have to multiply 2 on the right side as well. And I have a 2y on each side where I could just subtract them against each other, right? The equations against each other get a 0y. Or I can multiply this bottom equation by 1/2, thus allowing this 2y to become 1y, and then again subtract them against one another. I'm going to go ahead and try the first one. Move forward with the first one. By that, we're going to be multiplying equation 1. We're going to multiply it by 2, both sides. So what will that look like? Well, it'll be 2 times y on the left side. And on the right side, remember, I'm multiplying every factor here. So it'd be 2x squared instead of x squared, plus 3 times 2, that's 6x instead of 3x. Minus would be 2 times 5, so that'd be minus 10. So I've just really just doubled every one of those terms by multiplying through. Now, so we can just call this, we'll call this equation 3 then. That's our equivalent form of equation 1. So then what we want to do after that is we're just going to repeat equation 2. Just put that down below here. That was 2y. Again, we're just repeating it here. X squared plus 9x minus 6. Okay, again, I just repeated equation, what we call equation number 2. So now it's time to eliminate. Well, let's put a big old equal sign down here and just say we're going to subtract one from the other. So we need to be careful here. This side, it's pretty clear what's going on. 2y minus 2y. We got our 0y. We'll just put 0y. We know that's 0. Now let's be. I alluded to here just really previously that we need to be careful on this side. What we're saying here is 2x squared minus this x squared. So we're subtracting a 2 minus 1. So 2 minus 1, that's going to be 1x squared. Then we'll have a 6x minus a 9x. So we got the 6x up here. We're subtracting the 9x. That's going to be what? Well, that'd be negative 3x. 6 minus 9 is a negative 3. So we have negative 3x. And finally, definitely want to be careful here. A negative 10 minus a negative 6. So we're subtracting a negative, so we're adding, right? So subtraction of a negative is adding, so we'd say negative 10 plus 6. That's going to be a negative 4. Okay? So we know that this is just, this is all equal to 0. 0y, the same as just plain old 0 right there. Okay, so now what we want to do, we have a quadratic equation. We want to factor the quadratic. Now this is something you and I did first thing during our session yesterday. We want to factor the quadratic. So what is that? We're finding the roots here. We're trying to find the roots of this parabola, this quadratic equation. I'm just going to rearrange the equation. Okay, so we have the equation rearranged. We could do quadratic formula. I'm actually going to do it kind of the standard way. I call it reverse FOIL. You and I did that. So in this, we are just looking for factoring this into two binomials. First, we look at our first terms. What would our first terms need to be in order to get a x squared? Well, we know that need just to be x and x, right? X times x, kind of limited there. And these are going to be whole numbers, so 1x, 1x. Last terms, well, the last terms need to be such that when multiplied together, you get a negative 4, and when added together, you have a negative 3. Two choices really we can use here, either a 1 and 4 or a 2 and 2, where one of those, two numbers for each pair are negative. Let's go ahead and look at 1 and 4, and we'll make 4 the negative value. So we'll say minus 4, and the 1 is positive plus 1. What will that give us for when we add it? Well, we know, so 1 and negative 4, that's going to give us a negative 4 for our last terms multiplied. The outside terms, when multiplied, that's going to give us a negative 4x. Inside terms, when multiplied, would be what? It'd be a positive 1x, right, or positive x. And when we add those up, we get a negative 3x, which we can check then. Is that what we're looking for? Do we need a negative 3x? Yeah, that's what we set out to do. So it looks like that's going to be okay. That's going to be the one we want. Okay, so with that, we can find, since we have it factored, we have this quadratic factored, we can now look into what would the solutions be in terms of x for this. Well, if you recall, when we went through this yesterday, we looked at each one of these binomials separately. We looked at x plus 1 separately. What would x need to be there to be 0? We looked at x minus 4 as well. And we determined how to do that. Would be the best way to do that is just say, well, what if we said x plus 1 is equal to 0? or wanted it to equal 0, what would x have to be? Well, subtract 1 on each side. X would have to be a -1 for this guy to be 0, which would make then the whole left side of the equation 0, right? So x equals -1 is going to be one of the solutions. The other binomial, x minus 4, if we equal that to 0, solve for x, we get x equal to a +4. So in other words, when we have +4 for x, we plug that in there. We have this side on the right, on the left side, we have that equal to 0. So 0 times anything is going to be 0. These are our solutions for x. Now we're only halfway there. We have the x inputs, or the x values of the coordinates for the solution. Now we need to find their corresponding y's. How do we find that? Well, we take each one of those. If you recall, we take each one of these, x equals -1 and x equals +4, and we plug them. So this is at x equals -1, x equals +4, and we plug those x values into any one of the equations we've made. So we had, what equations were there again? Well, we had equations 1, 2, this is equation 1, this is equation 2. We have equation 3 here that we solved an equivalent expression, or equation, I should say. Let's go ahead. I would say let's go ahead and just use equation 1. We'll just say use equation number 1. And we'll plug in x, our respective x values, into that to solve for the y that corresponds with it. Well, for the first one, we plug in -1. We'd have y equals, it would be -1 squared, because it was x squared, plus 3 -1 minus 5. What would that give us? Y equals, that'd be 1, that'd be a +1. -1 squared is +1. This would be 3 times -1 would be a -3 minus 5. What's that? 1 minus 3 minus 5. 1 minus 3 is -2. -2 minus 5 is a -7. So one of our coordinates then would be a -1 for x and a -7 for y. So that's where these two equations would hit. That's where they'd intersect. And we'll look at that quickly on the graphing calculator. Let's look at this guy now. Let's look at x is equal to -4, or a +4. Move this over here, or move this up. Okay. X equals 4. So we're going to go back to our equation 1. We're going to say y is equal to 4 squared. That's a plus 3 times 4, because it was 3x, minus 5. We get y equals 16 plus 12 minus 5. And that's going to be what? Y equals 16 plus 12 is 28. 28 minus 5 is a +23. So for the second coordinate of intersection, we'd have a +4 for x and a 23 for y. Now, what does that look like? So what does that look like? Well, let's take a look at Desmos. I have the two quadratics right here on the left side on Desmos, and you can see where it intersects. Let's see, the first one, so the red one is what we called equation 1. The blue one is what we called equation 2. Our points of intersection are here at -1, -7. That was one of them. That was one that we calculated. The other one, we have to travel up here. Looks like right around here. There it is. Other point of intersection, 4 and 23. +4 for x, +23 for y. And that is what we had for our second solution.